Okay, so today we're going to do experiment 9, which is force tables. Here, when we have two forces acting at different angles, the third force, which is pulling the object to the center, that force is called as a resultant force or an equilibrium force. And if I give you an example, if I have this is called as a force table. And if I show you this, here we have a force table, and force table has a center. We have a ring. When this ring is in the center, it is called as an equilibrium position. And when we have two forces acting, pulling from either side, so if I have two forces pulling at different angles, if I want to pull this string, this ring to the center, I have to apply a force, and that force is called as a resultant force. And I'm going to show you by using Pythagorean theorem, I'm going to show you on the board how to calculate the resultant force. So let's say give an example. So if I have a force, if a first force acting on angle 90 degrees, the second force on 180 degrees, and this force is called as a pulling force. So how can I get a pulling force? So if you see the pulling force is otherwise called as weight. And what is weight? Weight is mass times gravity. So if whatever mass you are having, hanging mass, that times the gravity is called as a pulling force. That's the weight of the object. So here my initial first mass at 90 degrees angle is, which is 100 grams, which is 0.1 kilograms. The second, if I'm putting the second mass on angle 180 degrees, and that mass is 1.15 kilograms, which is equal to 150 grams. And now if I want to apply the third force to pull this ring in the center, and that force is called as a resultant force or equilibrium force. And equilibrium force is nothing but it's exactly the opposite of the resultant force, which is acting on the opposite side. So how do you calculate? So for that, you probably have learned in your lecture classes how to add two vectors. If I have two vectors, one acting this way and the other acting this way, how can we add these two vectors? I cannot add vectors using two tails. I need to add a tail of one vector with the head of the other vector. So these two vectors I cannot add. So how can I add this vector? I take this vector and place it over here. So now I can add these two vectors with the same magnitude. So this is the head of this vector is added to the tail of this vector. And that's what I did here. So if I have one force acting this way, the other force acting this way, I cannot add them. So what I did, I literally took this vector and I placed it over the head of this vector. So now I got the same vector, the same magnitude. And now when I connect the head of this vector with the tail of this vector, this is called as a resultant vector. So how do you calculate the resultant vector? I'm going to use a theorem which is called as a Pythagorean theorem. According to the Pythagorean theorem, it says c square is equal to a square plus b square. So if I want c, I do the square root of a square plus b square. So what is a here? Which is mass A. So if I plug those numbers, mass A is 0.1 kilograms and mass B is 0.15 kilograms, and I square them and add them and take the square root, and I got my C as 0.18. So this resultant R is 0.18 kilogram. That's my resultant mass. And when you multiply this times the gravity, that gives my resultant force. So how can I get the resultant force? As I told you, resultant force is, this is the resultant. So the force which is acting opposite to the resultant force is called as an equilibrium force. And this force brings this ring to the center. And that when the ring is in the center, that position is called as an equilibrium position. So this is how this is called as a. So this is how you figure out using the Pythagorean theorem. Now I need to figure out which angle I should place this. So how do you calculate the angle? So to calculate this angle, you need to know this angle. So how can I get the angle? Again from the theory part, how do you calculate? If you know A and B, how do you calculate the angle here? So this is the equation. So tan inverse B over A. So when I plug those numbers, tan inverse, what is my B? B is 0.15. This my A is 0.1. When I solve for this tan inverse 0.15 over 0.1, I got 36.3 degrees. So when you are doing this using your calculators, your calculator should be on degree mode. So once I got this 36.3, this 36.3, now you have to add this 36.3 to 270, because this is passing 270. So you add 36.3 plus 270, which is 326.3. So when you place your the pulley around 326.2 degrees and apply a force of a mass of 180 kilograms, 0.18 kilograms, the ring will come to the equilibrium position. And this is how, this is a Pythagorean theorem way of demonstrating the resultant force. So here, this is the table, so we have to fill the table. So I did the first trial, where I took my mass A is 0.1 kilograms. For mass B, I put it as 0.15 kilograms. And how I got this mass E, I used Pythagorean theorem, so I got 0.18. Now, how do you get the weight of A? When you multiply this mass with 9.8, here using mass times gravity, you will get this number. When you multiply this number, 0.15 times 9.8, you will get the weight of mass B, which is the pulling force. And how do you get the weight of equilibrium? You can do by Pythagorean. If you know this and this, you can use Pythagorean theorem, you will get the same answer. Or you can take the resultant mass and you multiply by 9.8, you will get this resultant force. So this is out. So now what you guys have to do is, you need to do the trial too. I gave you the mass, use the same angles, 90 degrees and 180 degrees, and use different masses now. I use for the first mass, I'm using 50 grams, which is 0.05 kilograms. And the second mass on 180 degrees, this time I'm going to use 200 grams, which is 0.2 kilograms. And now you have to fill these numbers the way I refill these numbers. So you have to use, to get this mass E, which is the equilibrium mass, you have to use the Pythagorean theorem to get this. And once you got this, now how do you get this angle? To get the angle, you take tan inverse, you use this equation, tan inverse B over A. Your B is 0.2 and your A is 0.05. When you do that, you get the angle theta. And whatever angle you get, you add 270 to that. And then this is the resultant E angle. Now, how do you get weight of A? You multiply 0.05 times the acceleration due to gravity, which is 9.8, you will get this value. Then you do the 0.2 times 9.8 and you will get this weight of B. Once you got these two weights, pulling forces, you can either use Pythagorean theorem to get this, or whatever resultant mass you get, you multiply this times 9.8, you will get this answer. So this is what, so when you are submitting this work through Blackboard, I need to see the entire, you need to draw this entire thing on somewhere on your lab books, and I need to see these calculations and try to fill it as much as possible, those back tables. And we are not doing the graphical method for this. We are going to do only these two methods, which is the Pythagorean method and the experimental method. Now I'm going to show you the experimental method, how I prove that Pythagorean theorem. I'm going to prove it here. So here I'm going to use different masses. So as I see, so this is a force table. Here is a 0 degrees, 90 degrees, 180 degrees and 270 degrees. And this again back whole circle with 360. So you see at 90 degrees, this is our first mass. I'm hanging 100 grams. And mass B on 180 degrees angles, I'm hanging 150 grams, which is 0.15 kilograms. Now I'm going to apply a force. So before I apply force, now if you see, these two forces are pulling this ring on this side, it's pulling the other. So if I want to bring this ring to the center, I need to apply a resultant force. And that force is called as an equilibrium force, because this position is called as equilibrium position. So let's see how much mass I should add. So now to add that mass, I'm going to keep adding the mass. So I'm going to add 50 grams, and you see this did not move. But if I add more, another 50, so it's 150, now it's going to be 160, 170, and this will be 180. And if you see this, and now it is in the equilibrium position. And if you see the angle is at 326. And this is how you can prove using the force table.